Hello, everyone. Welcome to NDC. I'd like to first begin by acknowledging the traditional owners of the land on which we all sit in Brisbane, where Anne and I are. That's the Turrbal and the Yagara people. We wish to pay our respects to the elders past, present and emerging. Today in our session, we're going to be talking all about event-driven architecture. Now, no event-driven architecture talk would be complete without Duplo, of course. So, we are making today at NDC a restaurant. We're going to start with our kitchen, where the chef is busy preparing their yummy food. We are going to have tables and chairs for people to place their orders with the waiter. We've got a cashier's desk so that someone can sum up the bill for all the things that they're ordering. And we have a stock room where all those yummy ingredients get put. We've got them all individually as their own responsibilities. So the big question is, how do we get them to talk together? And that's the question that we're answering here today at NDC. But to do that, I'd like to first introduce my friend, Anne. Hi, Anne.
Hi, everyone. I'm really glad to be here. And yeah, welcome to our talk. I'm Mwangi. I'm a senior developer at ThoughtWorks and based out of Brisbane. And Sarah has just introduced herself, and she's also from Brisbane, a principal consultant. And we're going to take you through this journey of how do we take an idea that we have that we want to do event-driven architecture, how do we take it? What are those decisions that we have to make before we actually get to production? And so, as Sarah has just introduced, all those different things are what we'll call microservices. So we do have the kitchen, we have the tables, we have the cashier and the storeroom. So those are all different services that need to talk, because the kitchen needs to know what needs to be made. And then the cashier needs to know what has been ordered from the kitchen. The stockroom will need to know what has been deducted so that they can do the shopping the next day. So let's look at one way that that could happen. Sarah?
Yeah, sure. Well, one way is that the waiter could take the order and then run around to the kitchen and wait, because it's a busy kitchen. So they have to wait until the chef's ready and place the order with the chef. And then they've got to run all the way over to the cashier's desk and enter it into the till to make sure that the cashier knows what to charge at the end. And then they need to come back and wait on more tables. That's one way that we could do it, but it's a little bit exhausting for the waiter.
So what if instead of the waiter doing all the round trips up and down, the waiter, when they take the order from the tables from the customer, they just shout, steak and chips for table 26. And at that point, the kitchen will be listening, and the kitchen will hear, oh, there's steak and chips needed for table 26. The kitchen will start doing preparing the order. The cashier will hear that steak and chips have been ordered, and that means it will. The cashier will also start adding that to the bill, and that's event-driven architecture. Basically, instead of having the service going to one service or the other, it just says this has happened, and all the other services know what needs to be done when that event happens. And that's what we want to talk about today, event-driven architecture. So now, event-driven architecture is not new. It's something which has been there for many, many years. But the question is why? Why is it that we're talking about it right now? Why is it such a thing, that such a hype right now? So we're going to talk about why now. We're going to talk about some of the concepts of event-driven architecture, and what are some of the questions and some of the challenges we faced as we were starting our event-driven journey, and much more. We're going to talk about the cross-functional requirements. So, Sarah, why are we talking about all this right now?
Well, and you and I have just come off projects where we've adopted an event-driven architecture style from them. They've been separate projects and they had similar characteristics, and it's the same similar characteristics that we're seeing across projects that we're working with at ThoughtWorks. So one of the reasons that we're seeing it is that as companies have been adopting microservices, they found that the coordination effort and the communication between the services that they employ is quite high. And that coordination effort is now starting to incur a lot of technical debt and a lot of work. And we're seeing the rise of event-driven architecture as a popular style to simplify that choreography. So instead of having a lot of coordination between our systems with a waiter running to and fro, we have a lot more choreography of just announcing what has happened and let other services deal with it if they need to. So that's one reason why we're seeing this rise in popularity. We're also seeing it on our legacy modernization projects as a way to accelerate that getting off the legacy system. So as new services are being built in new technologies, we can plug in an event publisher which latches onto the new event stream to publish some of the business domain events that are happening still within the legacy service, but that our new services might need to listen to and to enact. So it just helps accelerate that modernization as the legacy system can start publishing to those new services before that piece of code has been migrated across. And the third place that we're seeing it is going hand in hand with the rise of Kafka. So Kafka is getting very, very popular at the moment and seeing a lot of interest in it, especially with our data folk. And that is as a result of having lots of data available that people can use.
Yeah. And another thing that we have seen is also that right now, more than ever, technology is at the center of the business. It is the one that's driving most of the business. Like when you look at the businesses which are surviving, which are thriving, it is because they're using technology. And when you use event-driven architecture, and especially because of that data that you have, that means some of the questions that you didn't even know that you needed answers to, when they come, you can be able to ask those questions. For example, when you have that data about a restaurant, which day do people eat mostly fish and chips? Is it on Sunday? Probably, because our restaurant is near the beach. We're in Brisbane, so we love the beach. So is it near the beach where people love the fish and chips? So that means you can be able to derive analytics, decide when are we going to be ordering this? Oh, steak doesn't sell well on Sunday. We're not going to order that. And so this gives you the ability to ask those questions, make the analytics. And because you already have the data, when you have this event, and if you have the data already, then you're halfway there. You're almost, getting all those analytics. You just have to use them when you need them. And so that is another reason why it's very important. And so let's first do some introductions of some of the terms that we are going to be using. So what is event-driven architecture? We've been handling that. So this is where we have services, and we're talking about microservices in this point. And this is where we have microservices which speak to each other using events. But some of the terms that we are going to be using is, for example, in the kitchen, the service that is going to be giving the events, that is going to be shouting, that can be called the emitter or the publisher. And the one that is consuming can be called the listener, the subscriber. And why we are doing this is because different avenues, different places, you use different words, but still the producer, the emitter, the publisher is the one who publishes the events, and the ones who listens, or the subscriber, or the sync, or consumer, all these say the person who is actually getting the events, or the service that's actually getting the events. And then where we have those events, that's the event stream. And we're going to talk about this event stream as we go on, because there are different ways that you can have this event stream, but we are going to talk about that later. So when you hear those words, just know that is what we mean. So domain-driven design, how does this affect us? Yeah,
well, there's lots of terms that we hear that are covered under this umbrella called event-driven architecture. And before we really get into some of the questions and challenges that Anne and I faced as we developed our system, it's probably important to unpick a couple of those terms, especially because that was one of the challenges that we found teams having, just this mismatch between different and slightly different, subtly different concepts. The first one that you may have heard when thinking about event-driven architecture is domain-driven design. And the reason is domain-driven design is a fantastic tool, full stop, but it's also a fantastic tool to help understand what our domain events are. The processes that are contained within that Eric Evans Blue Book, which help teams identify the domain, the bounded contexts for which our microservices lie, and then expose the events that come between those microservices and they're existing within the domain that we're working on. If you follow a lot of the DDD practices, you should be able to very easily see which events are important into your system. So DDD is a very powerful tool that you can use as part of helping you to define what your events and what your microservices should look like.
Yeah, and another term that we'd like to talk about is event sourcing. And there are various flavors of event-driven architecture, but one of the ones that we're going to talk about is event sourcing. And this one is start from nothing and write whatever happens. So at the end of the day, you are not writing the end state, you're writing how you came to the end state. And for anyone who has used Git, like version control systems, you're going to use this, because when you start when you start writing code, you have an empty code base, and then you keep adding. Every commit that you add, you're adding something new. And so over time, you don't only know what you have right now, but you can see what have you added, what have you removed, what have you added. And that is the basis of event sourcing. And so when it comes to microservices, it will be very important not only to know what is there, but how did you actually get there? So the stockroom, for example, may want to know, what do I order? In the morning, it will just need to know, what do I order? And that is okay, because it can say, okay, so we need to order this number of fish, this number of steaks, and that's okay. But at the end of the month, the manager might want to know, okay, we've been ordering this amount of fish. Is everything okay? And the manager might notice, oh, in the kitchen, when people order fish and chips, we have 3 returns. And so it's not just knowing that, oh, we need to order this number of fish. It's about knowing what has been happening. Is it that the way we're cooking, the people don't like the way we're cooking our fish or something? And so that is good enough. So it gives the manager some insight.
Yeah.
But even, yeah.
I was going to say, so it's really important to understand that when we talk about the communication between the boxes, those big arrows between our big microservices, that's event-driven architecture. When we zoom in on one box only and we think about the persistent store and how they manifest what the current state is, that is where event sourcing really plays a part.
Yes, and it's also important because if, for example, the stockroom went down during the day and you only notice the next morning that, oh my goodness, stockroom was not working, what happens is that the stockroom can just replay all the events which happened the previous day, and it will know, okay, this is my new state right now, and I can be able to continue. The same way that you can get rid of all the code that's on your machine, and when you replay all, like when you git clone, it will display everything that has happened since the project was started. And so that is event sourcing. Start with nothing, write down whatever happens. So it shows you what has been happening.
So another term that we hear in conjunction with event-driven architecture is CQRS. Now, for those who are unfamiliar with it, let me just offer a quick explanation. CQRS, which is Command Query Responsibility Segregation, separates the doing actions in your system from the reading actions. So in our system, we're separating the writing down of what they order from the actual payment and the reading of the bill. So it's a way to separate. You could apply the HTTP verbs from it, so your gets are treated in a different manner to your posts or your puts. The reason why that starts to really become powerful is if you start thinking about different deployment technologies for them, different way that you can represent the data. So you don't have to have the same representation for reading and writing your data. And by following that to like a really full extension, you have separate components and services for reading versus writing, which means that you can put different availabilities, different caching levels over the two. Now, the first question that our teams faced when exploring event-driven architecture is, what technologies do we use? It's always the first question that devs tend to ask. What tech? So what's the tech that underlies it? Kafka, I've already mentioned, so popular, and I can completely understand why. Once you start using it, there's so many things that are just part of the ecosystem, like Avro for schema definitions, the SQL version. There's so many interesting things that you can do once you choose Kafka as your technology. Now, unfortunately for my team, it just seemed to be a little bit harder to operate. So we had a small team who was just migrating from data centers to Azure Cloud. They were learning that, they were learning agile techniques, they were learning C# development, and it was just introducing one more technology where they had to make a big cognitive leap, where their operations needed to be quite sophisticated. It just was that too much in the. But we wanted to get there eventually. We also knew that the volume of work that we were going to put onto our system, it just wasn't high enough to justify Kafka as we started out on our journey. So instead, we started to look around and we decided to use Azure Event Hub, because Azure Event Hub offers Kafka connectors. So we could still have a migration path from using Event Hub to Kafka eventually, but it just gave us that managed service to free us from the responsibility of operating such an intensive system. So we chose Event Hub for our project.
For us, it was kind of a similar situation, because we were refactoring a legacy application and bringing a new platform, and the team was new as well. And so there was a lot of learning involved. And so we also had to make a decision about, like, what are we going to do right now and what are we going to do in the future? And what we decided is, we're coming from Java to Kotlin, so there was still a learning journey right there. But also, we decided that we wanted to do events, but we didn't want to have to do all the event orchestration by ourselves. And so we used a framework. It's called Axon. And with the framework, it took care of all the event orchestration, all that stuff, so that we don't have to think about it at that point. And then, instead of having a central event stream, we decided to use atom feeds. So what will happen is, for example, in our restaurant, when the waiter announces that, we want steak and chips for table 26, it will not go to a central event hub. There will be an atom feed showing that there's an event which has been produced. And then every so often, the other microservices will be polling and checking, is there a new event which is happening? And so when that event goes out, the other services, for example, the kitchen will be polling and be like, okay, is there a new event? And so when the new event comes up, the kitchen will get that event from the Atom feeds. Now that did work for that time. And as I said, we were starting out. And so the end goal was to get to Axon has an Axon server where we can use it as a central event stream. But for the meantime, it was good enough to have Atom feeds, which are working for us. And this is why, because many people are thinking, oh, this is the only way to go. There are many options out there, and it depends on your team, the maturity, your risk, your risk appetite, how much you want to take on. And so it is good to start from where you are, start learning, and then the technology, there's always, you'll decide on what technology at the correct time.
So the next question that our teams were faced with was, what even is an event? So we had a couple of principles. We defined a couple of principles for our team. The first thing is an event is a historical record. So it is a record of something that has happened. It is the tense of it is it's in the past. So we record that table 26 has ordered the fish and chips. We record that table 26 paid $32 for their meal. Once we've established sort of what an event is, the next thing is, how do we group events? So Kafka has this notion of topics. And it's really just, in my head, an event stream. What events do you get to publish on that event stream? Do you publish all of your events that you could ever have on one stream, or do you have one stream or topic per event type? Now, the thing that you've got to consider is order important? And are these events that are being raised logically consistent within something that has happened? And for us, everything that happens within the restaurant, the table ordering, the food is ready, the stock levels in the kitchen, how much people pay at the till, that is all within that same context and the domain that we're working with. So for us, that went on the same event stream, on the same topic, because on the topic you have ordering, and ordering is important when you're trying to work out who did what and when. Now, imagine if our restaurant was actually located within an RSL. So you had the restaurant, but you also next door had the gaming room, and lots of things happening in the gaming room, the pokies, one-armed bandits, the poker tables, whatever else is happening over there. And they have their own event stream, and they're publishing the events onto their event stream, and they don't really play a part onto your restaurant event stream. So for that example, I would have my restaurant event stream and I would have a gaming event stream. And you may consider eventually down the track having just an RSL event stream where events from the individual areas get published onto for a very wide and very high level system overview. But knowing when or what to group on your event streams is going to be maybe the next level of conversations that you have within your team. There is no right answer. It's right for whatever context you're working with. I will urge you, though, to just be careful. One little thing when you're thinking about defining your events, and that is when the kitchen yells out, pizza is ready for table 28, there is an implicit assumption that the waiter is going to come and pick up that pizza and deliver it to the table. They are what we would describe passive-aggressive events. So they're events that are masquerading as a command. So really, the kitchen needs to issue a command to the waiter to say that the pizza is ready to come and do something with it. So instead of just sending an event out onto the event stream and the waiter implicitly knows that it has to do something, and for all those two things to happen, they need to happen completely for the business process to happen. We decided to create a new event stream for asynchronous command messages instead. So instead of it being issued out onto the restaurant's event stream, there was just a slightly separate command-based event stream. We used to use the same technology, but just to keep that async processing in place. It didn't have to be async. We could have just done REST API calls to from the kitchen to the table, and that would have been absolutely fine within our architecture. We wanted the async communication flow, so we just broke out a separate event stream. For one publisher, one consumer. We know that it's a command-based system, events coming out, and that is completely separate to the event-driven architecture that we're really talking about here. So just beware of those passive aggressive events that come through.
Yeah, and for our team, we decided to have a REST API for those commands. And so it was very separate that this is a command and it's actually telling, so this is the kitchen telling the way the storeroom do something. And so that was on REST API, but the rest of the events were actually in the event-driven architecture, like with the atom feeds. And that really separated it really well. So
yeah, I was going to say that was just us separating those commands onto a separate separate stream.
Yeah. Okay, now before we go to development and testing, just reminding you, if you have any questions, we have a Slack channel, so you can write your questions on the Slack channel. If you have any questions here, we'll have a look at them. We have dedicated time at the end of after we speak, we're going to answer the questions, and then we'll continue the conversation later on Slack. So feel free to add your questions on Slack, and we're going to have a look at them. So the other question we ask ourselves is how do we develop and test our applications? Now, I don't know about most people, but I do love, and my team really value having our laptops or being able to develop on airplane mode, meaning that we don't have to be connected to the internet or to the event stream to be able to do the work. Now, that is good to hear. But then if you have to run all the services on your machine, especially if it's a big platform, then that means you're not going to do anything because it's going to overload your system. So how do we develop all this? How do we develop our system on our machines, having all the things that we require? And how do we test that? Now, I'll say about what my team did, and then Sarah will come with what her team did. So what we did is that we had Docker containers. And so, for example, when I was developing for the kitchen service, I would have the rest of the services running in a Docker container. And then the only one that I'm working on is the one that I'm running locally. And so I'll be able to write the code on the kitchen service and still make sure that it is working together with all the rest. It also happened that in that team, we were responsible for all the services. And so for example, one story will touch the kitchen service. It will also touch the stock service. And so I'll be able to see how it all works together. But we have been in other teams where, for example, the kitchen service is being managed by our team, the stock service is being managed by the other team. And what we have done in such a situation is having contract tests. So making sure that what the stock service promised us is what it is doing. And so that was helping. And so for us, using Docker containers to be able to run the rest of the services, to be able to test that whatever I'm writing right now is going to work everywhere, helped us. And if, for example, you don't have all control, then the contract tests were very useful. And for Sarah, how did your team deal with this?
Yeah, well, because we were using Event Hub and that was the cloud, it was a little bit more challenging. Well, not challenging, but we couldn't have the cloud on our computer necessarily. So instead, we decided, because Kafka was the point that we wanted to get to in the end, we grabbed a Docker Kafka instance to run locally on our machine. The one the one mistake that we made was that before we knew, although we knew we wanted to introduce event-driven architecture, we also knew we didn't want to start with multiple microservices. So we started with a well-factored monolith with the idea to break it up. And the gotcha that we really played was when we started with just that one service, we had to eventually do a lot of refactoring to have that notion of events to be really in there, because we ended up refactoring towards the mediator pattern, because the mediator pattern lets you build and think about events and commands really nicely within your service. So once we had those internal events firing to make our microservice work internally, we then translated a few of them to those external business level events and put them on our external system. And I really wish we started with that mindset that we would be publishing them to somewhere, even if we didn't have that technology in place. We also came a little unstuck halfway through, or, as we progressed our development, just with this constant never-ending stories. We were both building our features and building our platform at the same time, and we found that these stories were taking longer and longer to develop, because our vertical slice was getting deeper and deeper. So we love working in vertical slices, but we had to make the boundary very clear in our system. What we decided to do, because the platform wasn't there and ready, and we were trying to do it at the same time as feature stories, within the one user story, we decided to separate that platform and that platform engineering out from our development of the story, the user story. So in parallel, we had a stream, a pair of developers working on our platform, our event hub, doing the SRE, over getting that ready to go, doing some testing and publishing some examples. And then we had the user story pair working slightly behind them to use and make use of that platform. And when the user story development got to a point where the platform team weren't quite there, the platform pair weren't quite there with getting the platform, they just paired up and worked on that in conjunction on their own separate stories. So knowing where and how, and constantly monitoring those stories, and constantly thinking about what is the problem that the team's facing, and how can we solve it in slightly different work, allowed us to separate the work and make those slices grow a lot quicker.
Yeah, and after asking ourselves those questions, we'd like to also think about some of the cross-functional requirements that we were thinking about. Now, some people may call them non-functional requirements, but we prefer to call them cross-functional, because we actually need them for any system to happen. And so one of the most important we quickly realized was observability. Now, we all know that we need to know what's happening in our services. And much more when you come to a microservice architecture, it even becomes more useful. Now, with logs, it's usually very tricky, because if you just write logs for everything, then there'll be too many logs, you won't know what is necessary. And if you write too little, then you won't know what is happening. And then there's the other fact that, how do you get to know what happened on service A that led to service B failing, or that went to service B and service C is failing? So you'll see service C failing, but then how do you make all that connection? And one thing we had to make sure is that we had a correlation ID. This is a ID which is sent through so that you can be able to have that tracing of the challenge, all the places that it has gone through. And that was really, really important for us because it meant that we just don't go through that whole log, all the logs blindly. At least you have an idea. You can be able to know, okay, this is what I'm looking for. And then you can be able to know what is happening faster and decide what to do about it. So that was very, very important. And the other thing is knowing the log pattern that you're going to use, because you might have one pattern in one service, another pattern in another service. And when you go to look at them in, or in your central logging, in central monitoring, then you don't know what is coming from where. But when we had that log pattern already established, so it was very easy even for the eyes to spot what is happening. And that was very, very important in understanding what's happening, where it is happening, and how do we deal with the challenges with observability. So as you're building your microservices, as you're building your event-driven architecture, take some time. And this is not something that you can do from the first day. It's something that you learn. But with the correlation ID, it was a lifesaver. And the log patterns, when they were all organized and well, they really made our lives much more easier.
Yeah, that's a big gotcha on our team. It's something that we knew, but we forgot. We definitely forgot that we needed to have that same log system, and we started to have gremlins in our system, and it was very difficult to look through Seek to work out what was going on because we couldn't apply that same standard SQL on top of it.
Yeah. And that's why I like them when they're called cross-function requirements, because they actually are cross-function, like you always need them. And the other thing we had to think about is performance. Now, at the beginning, everything is working so well, there's no much happening in the system. And then with time, you realize that your performance is going low. And thanks to good observability, we were able to realize what's happening. Now, for different systems, it will be different things. I'll just give an example of what was happening for ours. One of the things we realized is that for us in our system, we were using event sourcing and we had domains. Now, we were making an application system. And in that, we had the biggest domain who was a customer with a lot of data coming through. And then it happened that every time there's an event which has, like when there's that domain, the customer domain, with event sourcing, there's something called snapshots. Snapshots are every 50 or every 100 events, you're going to take a snapshot so that every time the next service comes, it doesn't have to replay all the 50 events that have happened. So there'll be a snapshot. At first, we were making 100 events before a snapshot happens. And then we noticed that if, for example, you're at the 99th, when the next service comes, it has to play 99 events to know the current state of the world. Sometimes it's okay, but we had a lot of data, and JSON deserialization and serialization came in, and it was making everything so slow. But then when we made the snapshots only happen after 10 events, so every 10 events will take a snapshot, and so that every other service that comes, it doesn't have to play all the 10 events. It just looks at the snapshots and starts from there. It made the performance really, really fast. And so that was helped by the observability. The other thing that we also had problems with asynchronous services, and how do we make sure that everything is happening at the right time. But above all, with good observability, understand where the performance is going down and looking for, innovative ways to deal with the performance. Did you have an issue with this, Sarah?
Not with performance, but definitely as we moved more to that distributed architecture, we're breaking out of the monolith. There's a lot more thought that has to come through certain cross-functional requirements. But I'll tell you that there are other cross-functional requirements that kind of get gimme, like for free. So availability is one of them. Imagine that the stock room did go down over the weekend and the orders weren't being processed. It wouldn't matter, because as long as the stock room was developed so that it could just replay from the last read event, everything would be happening fine. Same with the kitchen. As if it went down and then came back up, as long as it got knew where the last read event, it could just replay all those events and then continue as normal. So the availability of the system was actually helped because of its distributed nature, and because by its nature, the services had that inbuilt like replay notion. Now, the one thing that teams do have to get comfortable with is the fact that the world will not be synchronous. So our real world isn't synchronous. So why do we expect our systems to be? Like I moved address recently, and I made sure that the tax and the voting electoral system and my bank knew my details, but my hairdresser still has my old details, and my gym had my old details until I went to update my credit card recently. The world didn't collapse by having inconsistent data across these services, but we seem to think that our computer systems will collapse if if the data isn't consistent. So I'd say embrace eventual consistency, embrace the notion that your microservices are not going to have the same data, but as long as they get there, as long as it's eventually populated throughout your system, and when you need it, it's available, or if it's not, you can double check that it's the right address or the right piece of data or the right order, then you can embrace and live with that eventual consistency. And the other thing that you get for free with event-driven architecture is reporting and analytics. Because your events are domain events and you're publishing them on your event stream, it's very easy to hook your business intelligence, your data lake, whatever it is that you're using to do your reporting and your analytics into the event stream to harness those events.
Yeah, and this is one of the good features that you get, and we can properly use it to help our businesses understand more of what is happening. And so, yeah, that's what we had for you today. Those were beautiful images. Yes.
Yeah, if you would like to build your own pizza shop with Duplo, you could buy this pack at the shops, and they've got the instructions on the internet. So you go to your kids, raid your kids Duplo, raid your old 30-year-old Duplo stock if your parents still have it, and make your own pizza shop at home by following the instructions in our slides.
Yeah, and we're going to share these slides after this. And so, questions?
Yeah, look, as we move more into microservices, as we try and clear out some of the coordination overhead and orchestration that's required, maybe you are considering event-driven architecture as a way to simplify that choreography. There's one thing knowing the concepts and being able to explain the concepts, but getting your first event into production, you will face similar questions, and we know it because both of our teams face them, and a whole bunch of other projects that we were talking with also had similar questions coming up. So I hope today's talk has shone a spotlight onto some of the questions that you might face as you build out your system, and explore some of the solutions that you have as possibilities. But no two systems are alike. Everyone's context is different, but hopefully there's enough fodder for you to start thinking about and start getting your teams to brainstorm the right answer for you. But yes, if there are any questions on Slack, We will have a look at them. Just need to modify my Git setup.